Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about the equation of a straight line. The key point says the equation of a straight line graph can always be written in the form of y equals mx plus c. This is the form of the equation of a straight line, in which m is the gradient and c is the y-intercept. So as you can see here in this equation here, y equals mx plus c. So m here is the coefficient of x, and it's the gradient all the time. So if you have an equation, the number multiplied by x is the gradient. And then you will have c alone, in which it's the constant, and it's the number alone. So it's the y-intercept. So any equation that has a number alone or a constant, the constant is the y-intercept. And if you don't have a constant in this equation, it means that the y-intercept is 0. Very good. Now, we can take a look at some questions to understand this key point and answer questions using this form of equation to find the gradient, which is m, and the y-intercept, which is c. Let's take a look at some questions to understand that more. In this question, we're going to match each equation from this side to the line on this side using the things that we learned about the equation of a straight line, which is y equals mx plus c. So we're going to use first the y-intercept to find the line, and if we have the same y-intercept on two lines, we're going to use the gradient to differentiate between these two lines. Now, first, let's take a look at the first equation here. What's the y-intercept here? Very good, it's plus 3. Now, let's take a look at the lines and find plus 3 on the y-axis. Now, on the y-axis, plus 3 is here. So, the line or the green line is crossing plus 3, and it's c. Now, we match c here to this equation. We write c. Good job. Now, let's take a look at the second equation here. In this equation, we don't have a y-intercept, or we don't have a constant or a c. That means that the y-intercept is 0. Now, this is not the only equation here without a y-intercept. We have this equation too. So both of the equations don't have a c in the equation, and they don't have a y-intercept, so the y-intercept is 0. So there are two lines crossing the 0 here. We can take a look at the 0 point here. We have two lines, the pink one and the purple one, in which F and E. Now, to differentiate between them, we have to find the gradient for each one of them. Now, let's talk about the gradient here in this line. The gradient is the coefficient of x. So it's the number multiplied by the x. So the gradient here is plus 3. Plus 3 is here. Good. This is the gradient. And for the other equation here, the gradient is the number multiplied by the x, so it's negative 2. So we will take a look at the two lines that are crossing the 0 point on the y-axis, and we will differentiate between them using their gradients. Now let's take a look at the two lines here. We have F and E. Let's find the gradient of F first. Now to find the gradient, what do? We have to go one positive step on the x-axis, like this, and then we try to go back to the line again by using the y movement. Now to get back to the line, we have to come from here till here. Now we went down, it means that the gradient is negative. Very good. So the gradient is negative. Because we went down, the gradient is negative. Now, how many boxes did we go down? Very good. We went 2 boxes. So the gradient here is negative 2. Very good. So F, or the line F, the gradient is negative 2. Now let's take a look at line E. For line E, we're gonna start from a point that we can see the line. We can do it here. So we start from the line, we go positive on the x-axis, one box, and then we try to go back to the line on the y-axis here. Now, to go back to the line, we went up. So the gradient is positive for this line. And then how many boxes did we go up? Very good. It's 3. So the gradient is positive 3. So we understand that the gradient for f is negative 2, and the gradient for e is positive 3. Now let's find the gradient negative 2. Very good. This one is the gradient negative 2. It's for f, so we write f next to it. Let's put it here, so it will be possibly visible. Good. And then for the one positive 3, we said it's e, which is here. So the gradient positive 3 is e. We put e next to it. Very good. Now we move on to answer the other equations. As I said, finding the y-intercept will help you find the lines. But if you have the same y-intercept, you have to take a look at the gradients. They will help you to find or differentiate between the lines. Now let's take a look at this equation. What's the y-intercept here? Very good, it's negative 1. So we go and look for negative 1 on the y-axis. Negative 1 is here. And the blue is this point. So the blue line is the one with this equation. So it's B. Very good. So here we write B. Now, what about this equation? What's the y-intercept here? Very good. It's positive 1. So we take a look at the lines. We find positive 1 on the y-axis, which is here. The red line is crossing it, so it's A. Very good. So we write A here. And then we take a look at the last equation. The y-intercept here is negative 3. We take a look at the y-axis. Negative 3 is crossed by the orange line, which is D. So we write D next to it here. Very good. And this is how you answer a question like this. First thing you do, you find the y-intercept, and then find it on the y-axis. And look which line is crossing this y-intercept or this point, and then match it to the equation. If you have the same y-intercept like we had here for this and this, find the gradient to differentiate between the 2 points or the 2 lines. Find the gradient. You will find, or you will know which line is matched to the equation. And this is how you answer a question like this. Thank you very much for watching. See you next time.